Now we look at section B, the last question of the paper. Question 13, we have a sailboat which is in equilibrium while a man of weight 750 newtons stands on the sailboard. So first part, define the principal moments. I won't go through this because this is a standard definition question. Question 13b part I. Okay, taking moments about pivot P in figure 13.1, which is this pivot here, suggests a reason why the moment caused by the weight of the sailboat about the pivot at P is 0. So a very simple and obvious reason is that if the weight by the sailboat at pivot P is equal to 0, and we know that the sailboat will definitely have a weight, this tells us that the center of gravity of this sailboat must lie directly above pivot P. So, to answer this question, very simply, you can either say that the perpendicular distance of the weight to the pivot is 0, and therefore you must link to the question, which is why the moment caused by the weight is 0 is, and since I know that perpendicular distance between the weight and the pivot is 0, hence the resultant moment due to the weight is 0. Okay, this is for B part I. Part 2. Calculate the wind force acting on the mainsail. So we know that the question says that this person is in equilibrium. So from here we can see that if this object is in equilibrium and the pivot point is here, there are two forces acting in this system. First, I have the wind force, which exerts a clockwise moment in this direction, whereas I have the weight of the man exerting an anti-clockwise moment about pivot P. So therefore, by the principal moments, I can formulate an equation. Okay, so by the principal moments, I know that the sum of clockwise moments is equal to the sum of anti-clockwise moments. So therefore, from here, I should be able to obtain an equation which is that the clockwise moment is due to the wind force. So therefore, I let the wind force, I call it be F. Moment due to wind force is F times 1.6 meters is equal to the weight, the moment caused by the weight, which is x in the anti-clockwise direction. So maybe I'll just label here. This is in the clockwise, this forms a clockwise moment, whereas the weight here causes an anti-clockwise moment. So therefore, we can see that if I formulate this equation here, the sum of anti-clockwise moment will be the weight of the man, which is 750 Newton, times the perpendicular distance between the weight and the pivot, which is 0.6 meters. So therefore, we can easily solve for the wind force F, which will be simply 280 Newton, rounded off to two significant figures. So this will be the answer for question B part 2. Okay, moving on to question B part 3. If the wind force acting on the mainsail increases, suggest how the man can attain or maintain equilibrium. So going back to this diagram, essentially the question is saying, what happens if this wind force here increases in this wind force here? And the result of having an increased wind force is that the clockwise moment due to wind force will increase even further. So in order to attain or to maintain equilibrium, something must happen to the anti-clockwise moment such that it balances out the clockwise moment due to the wind force. And we know that from this scenario over here, the weight of the man cannot change. and the man is just holding the wind sail in this position. So the only thing that can be changed, since we know that the anti-clockwise moment is this due to the force times distance, and this force is the weight, which we cannot change, which means that the only other thing we can change is the distance between the weight of the man and the pivot point P. So simply what this man can simply do is very simple. The man just needs to, or the surfer, the man can lean further away from the sail. Okay, then we follow the question. You are supposed to suggest a method first, then after explain your suggestion. So next part, after suggesting this method, I will explain why this helps to maintain equilibrium, which follows the same concept. Okay. So therefore, when the man lean backwards, the line of action of weight will become is further from the pivot. So therefore, this will resulting in anti-clockwise moment about the pivot to increases, and when this increases, it increases to balance the increase in clockwise moment by the wind force. Okay. So therefore, this will be the explanation to question B part 3.